Repeat again, your exam is on Monday, morning 9 to 11. Okay, you are allowed to come in the room 10 minutes before that. Okay, make sure you bring your calculator. Don't forget your calculator. The place at the P1414, the SIT block. For all the three groups, F1, F2, F3. Okay, you are not be doing alone, you'll be doing with other diploma. Okay, I think got 3 diploma down there. Okay, repeat again. Okay, the exam is 3 sections, section A, B, C. Section A, 20 multiple choice question, 2 marks each. They'll give you 40 marks. Okay? Make sure you can score 10 questions right. Must score 10 questions above. If not, you have problem. Okay? Section B is a compulsory 3 questions. Okay, each one 10 marks. Okay? So pay attention to their division. Section C is a 3 open question, choose 2. Each one is 15 marks. Okay? Okay, before you start, whenever you do multiple choice question, you must think of this Bernoulli's principle. Always think of Bernoulli's principle. Remember, this side is always your what? Your turbine. The other side is your compressor. It's reverse. This is turbine. This is compressor. Okay? You must think of Bernoulli's principle. Not your conventional thinking. Okay, you also need to understand your basic of your engine construction. Okay, where is the intake, followed by compressor. Then the next one is diffuser. So what is the purpose of diffuser? The diffuser is just an empty space. It's a diverted empty space. It's to enlarge the volume. Diverted. To give you what? To increase the pressure. There's some drop in velocity. Then your combustion section. Then your turbine section. Remember, turbine is to drive the compressor. It does not produce thrust. Its purpose is to drive the compressor. It takes out energy. That's why it becomes a negative thrust. Okay, turbine is a negative thrust. Okay, when you recall back your Bernoulli's principle, what is the shape of the intake for subsonic? Okay, here, this portion here is always slightly divergent for the subsonic aircraft. For supersonic aircraft, it's this way. It looks like a Bernoulli's diagram. The intake and the exhaust the same for supersonic aircraft. Okay? Just to remind your principle, your thinking, when you come to multiple choice question. Okay, this again just to recap again. Remember, the front portion is your turbine. The behind portion is your compressor. You refer to Bernoulli's diagram. Turbine section is always what? Convergent. Okay? The compressor section is always divergent. Yeah? Okay, next one is to improve your engine performance. There's one thing they need to avoid is a vibration. Because your engine is turning at very high speed. A slight vibration can cause damage. So they must avoid vibration. So they introduce stroke. Okay, something called stroke. Because turbine blade or compressor blade, they're very thin. Okay, they got cantilever effect. So this is to have a bit of a mid-span stroke for fan. Okay, and for the turbine, and the tip there, they put on stroke. Okay, what's the purpose of the stroke? Is to reduce the blade tip gas flow losses, reduce losses and blade vibration. Remember, your blade at the tips there, the speed down here and the speed here are different, okay? It will cause respiration vibration at the tip. So to remove the vibration from, they have to stop it. You got to close it. So you have to reduce the vibration. By doing this also the second benefit, it prevents tip losses. Okay? For the fan, because the fan blade is very long. Especially the super bypass engine, the fan blade is super long. Okay? You need to have a mid-span stroke to support it. If not, you have a lot of vibration. Okay? Remember your KL twin tower. Twin tower is too long, in between they might have a structure to connect the two parts to prevent the tower to get vibration during the wind blowing. So need to have a stroke. The concept of stroke to buy you stability. Okay, you also need to know axial flow. The purpose of axial flow compressor, every section here, the compression rate is very small. But because of cascade effect, it becomes a larger compression ratio. Okay? Compared to the centrifugal compressor. Okay? So this diagram will show you that to have a compression increase, the volume here must getting smaller and smaller. To have pressure increase. But at the same time, we need to stabilize the velocity. We don't want it to decrease or increase. Remember, this one is a divergent duct. The velocity is supposed to reduce, but because of rotor effect, the velocity increase. They cancel out each other. The velocity becomes fairly constant. Okay, to recap your mind, how to answer your multiple choice question. Okay, talk about this formula. A lot of people still cannot get the meaning of this formula. Okay, the basic simple engine thrust equation is always three parts. This is a momentum of the air, the fuel, and the pressure difference. Okay, remember your thermal fluid, the subject. They already mentioned to you, at every stage of the process, the energy remains the same. Whether at inlet, this is inlet, whether at process and exhaust, the energy at each level is always constant. Okay? So how you measure, because for turbine engine you cannot measure the exhaust, it's too hot. And also it exhausts out. You cannot have energy to capture all the gas and measure it. So normally people measure at the front. To measure at the front, you need to consider basic three components. The momentum change by the air, momentum change by the fuel, and the pressure different by the gas. Okay? The term used is momentum change. Remember your Newton's second law. When there is a change of momentum, the force appears. Whether the change is positive or negative, there will be a force in the direction of where how it applies. Clear? That's why you need to know the momentum change. Different from the other formula. your state flow formula is slightly different. This one you talk about momentum change. Momentum change is a velocity change. That's why you got a V2 minus V1. Okay, this is called a momentum change of air. But for the fuel side, okay, because your subject is to study theory and apply. You did not study theory to do research or design. So this portion here, normally we take it as 0. Okay, it's the comparison to the overall momentum, the change down here is only affect around 1%. So we take it 1% as negligible. We make it as 0. Okay, so you make your calculation more simple. Understand? If you study thermal rate, okay, you're supposed to calculate this figure also. But down here we treat this one as 0. Okay? And this is the pressure different, the overall pressure different of the engine. Area temperature different. Now this one you got 3 components down here. And this one is referred to the whole engine. This formula is applied for the whole engine. The process is referred to the whole engine. The in, out of the engine. This is a velocity change. Yeah? It's different from the state formula change. Don't get confused. Yeah? Remember all your unit here in pounds, pound per second, feet per second. Okay? Normally we don't like you to get confused with the SI unit. Okay, we don't get the unit change at all time. Okay, we fix the unit like this. Okay, now you have to convert to all these feet per second, pound per second. So we simplify it for you. You don't have to convert all this. It's already given like this. Yes.
Will it be given in the formula sheet?
Yes, the formula in the appendix, the last 2 sheets. Remember your first day of the lab lesson, the same sheet are given to you. Okay? You say about static pressure, and static atmospheric pressure. This one is taking from 0. It's an absolute. Okay, that's why you do minus this one, atmospheric pressure. Normally people take the atmospheric pressure the PT2. You take it as PT2. Okay about this? That's why you need to know the difference, the gate pressure or differential pressure. No, they better to keep here. Okay, same thing. This diagram here is to show you the diffuser. Remember the formula for Penton cycle is constant pressure when the gas expands. So from the diffuser all the way to the nozzle guide vane, supposed to be a constant pressure. Okay? But because of losses there, the pressure suddenly dip down. Okay? So the higher pressure usually is exactly at the inlet of to the combustion chamber, or you refer to the diffuser chamber. Yeah, so your PT3, PT3, correct? Your burner pressure is measured at this point, diffuser pressure, or PS3, we call it burner pressure. Here we call back your ATA 73. The 4 primary input to your FCU. Excuse me, no need to tap. Okay. So this one is your PS3, your burner pressure. It's one of the very important input to the FCU. Your higher temperature is at where? Nozzle guide vane. Higher thrust also at nozzle guide vane. Remember your state formula, everything you calculate the state. The highest absolute thrust is at here. Nozzle guide vane there. It gives you the highest potential energy. That's why I show you this picture here, to have you have the idea. Okay, now you compare the other formula to this formula. Area temperature. Okay, we will refer to this pressure change. If they give you static, you have to minus off the atmospheric pressure. Atmospheric pressure usually as static as the mid-sea level is 14.7 psi. Okay? But normally will give you the pressure difference. Not the static absolute value. Understand this? Understand. During your lab lesson, all your stages, the pressure given there is a pressure different. Already different already. Okay? You take as amorphous at 0. Remember the V here, there is no V change. Huh? The V down here. There's no V1 minus V2 minus V1. It's the V at that stage. Okay? So you minus your I. Your absolute value of the inner side. Clear? Clear about this? So you don't know, so I suggest you when you go back, go and do the exercise. Remember your computation 1B, yeah? Go to practice it one more time until you understand all these points. If this one is your outlet, this is your inlet. Okay? You treat this inlet. If this line here is actually your atmospheric pressure, you take it as 0. You take them as your reference. So your difference of I is the inlet here is 0. Here is outlet. So actually is here. Okay? You refer to next stage, the combustion chamber state. Combustion outlet is here. Because you use this formula, you're going to have this point here. You minus the I, this is the I. From here to here, the I. Okay? You're going to have a difference here. This is your positive value. Okay, this is what you're going to get, the FG. The FG is down here. Okay? Now you take out here, the turbine exhaust here, outlet. The turbine inlet is the highest. Remember the noses guide vane. I give you the highest potential thrust energy. You minus all, you're going to see your value is minus. The FG is minus. Okay, this indicates to you the turbine is a negative thrust. You don't produce thrust. Actually, you take out energy. You make the thrust lesser. That's why you call negative thrust. Okay, I'm going to go by the idea. You practice your computation number 1B, you understand all this formula. Clear? Okay, for the oil, we quickly jump this one. Okay, for the oil, repeat again. When you come to the fuel cool oil cooler, please the term here. Use the fuel to cool the oil, so the oil temperature is critical. The main purpose is to cool the oil. The byproduct is to heat up the fuel. So don't get it confused. The main purpose of fuel cool oil cooler is to cool down the oil pressure, oil temperature. Okay? So you must have a device. This is called a heat exchanger device. Okay? You put heat exchanger. Byproduct is to increase the fuel temperature to cool the oil. If the oil is already very cool already at the inlet, you will no need to heat up the oil. So all the oil will be bypassed by this thermal stage here. Okay, if the temperature is cold, the spring retract, the valve open, and the oil will bypass. It's a real concept. Okay? The temperature is high, you close back, the oil will go in. You cool the oil, maintain the oil. Yeah? Another one, when this door is open, when this one is clogged, this one is closed up, the pressure will build up. You push this door open, the oil will bypass. As nothing is happened to the oil system. Remember, it fail safe. Engine must be, the bearing must be lubricated all time, okay? So if this one is clogged, maybe we don't want this one anymore. The oil must flow as normal, okay? There's nothing happen at all. So you must bypass it. Yeah? Whether you need to heat up the fuel is secondary. You must solve your primary problem first. So today I fully bypass it. So the oil system is operating as per normal. Nothing happened. Okay? Of course the fuel is getting cooler lah. But this is secondary purpose, okay? Your engine still operate, but lost a bit of efficiency. What you want is fuel safe. Okay, so keep in mind, fuel cool oil cooler is to control the oil temperature. Oil temperature is critical. Yeah? Okay, come to the fuel. Remember your topic 4 is oil. Topic 5 is fuel. Aircraft fuel. When you talk about aircraft fuel, topic 6, topic 5 to topic 6 is your engine fuel. These two things are related together. You need to have aircraft fuel system, then you can have engine fuel system. They are related. Okay? So to meet these two requirements, there is some rule down there. Okay? When you design the aircraft fuel system, you must follow the basic feature. Okay, this feature here. Okay, it's a design rule. You design this system at time, you must follow this rule. Okay, the all engine can be fed from all tanks simultaneously. Okay, maybe tank to tank feed. This is a basic requirement. Left tank feed left engine, right tank feed right engine. This is a basic requirement. Okay, all tanks can be filled through a single receptacle. When you do refueling, you only refill for one point, but you can fit to all tanks. You must have this design. Any engine can be fed from any tank. Yeah? One tank is enough to feed all the 4 engines. Let's say you got 4 engines. This is in terms of fuel safe, redundancy. If all the fuel boost pump fail, there's only left one pump. So one pump must be able to feed all the 4 engines. We are talking about the fuel boost pump. Not engine pump, it's a fuel boost pump. You got to push the fuel from the fuel tank towards the engine by using fuel boost pump. Okay, the purpose of fuel boost pump is to boost. Okay, is to create a pressure head difference for the fuel to flow to the engine. The purpose is to remove what?
One direction.
Why you must have a positive pressure when it comes to the engine side?
Cavitation.
Cavitation, okay? Because on ground they don't have such problem because you're under high atmospheric pressure. But in air, the atmospheric pressure is thinner and thinner. Okay? You don't have positive feed, you tend to have cavitation problem. Remember Pesicora, you open up, a lot of gas come out. The same thing. You don't have the pressure, free pressure head to press it. During in flight, all your fuel will contain air bubble. Okay? When your fuel burning the time, you will be not constant. Your fuel is not constant. It can go off anytime. So it is no good. Okay? But some people will ask, what about gravity feed? Gravity feed is no choice. When all the pump completely fail. Then you talk about gravity feed. Okay? That is fuel safe. There is no choice. Okay? But in normal design, you might have at least one pump working and enough to provide pressure for all 4 engines. Okay? So this is a design requirement. Okay, any engine can be fed by any tank. This is the requirement. A malfunction tank. Let's say one tank, the pump not working or the line broken. Fuel line inside there, the tank broken. Okay? The fuel cannot pump out. Okay? So you must isolate this tank. Able to cut it off. Yeah, this is called isolation. For example, here, this room got fire. You don't want the fire to spread to another room. So what you do? You ask everybody get out, you shield up the place. All the door, window, everything sealed.
See.
Okay, let the fire burn inside. By doing this, the structure itself can hold the fire for a while. Okay, before the firemen come. Okay, so this is called isolation. You isolate it. When you watch movie about a submarine, somebody to puncture a hole. All the crew will run out. The room that punctured the hole, you have to isolate it, seal it off. Yeah, it's the same concept. If this tank, the fuel pump system fail or something wrong, you got to isolate the tank. Yeah. Next step is to think how about the fuel remain inside. You need to think of a way to transfer the fuel out. Okay. But for the basic level, you need to have these 4 features. If you want to be a designer, you better know about these 4 features. Okay, these 4 features. In between your topic 5 to topic 6, your fuel tank to engine fuel. These 4 features must have. Okay. Then you need to clear about the big aircraft. The design about the engine tank. What is the concept? So Lego bridge, small Lego bridge. Okay. The main purpose is this one, the heart, the pumping, your fuel boost pump. Okay, because this pump will pump the fuel, go to your engine. To give you a positive heat to prevent cavitation. Okay. By doing this, you must ensure this pump is always immersed in the fuel. So this is your concept, Yeah? So to achieve that, there are people are very smart. So they build a tank within the tank. There will be a tank housing this boost pump. Okay? So they put a flapper check valve here. When the fuel come into here, when the aircraft maneuver, when the aircraft tilt, the fuel going to flow out, right? But because of this check valve, the fuel was trapped inside. So this pump will not be exposed. It's always submerged in the fuel. Okay, Okay. Now what happens when the fuel level is getting lower and lower? Doing this check valve is not enough.
Okay, check valve of flapper valve.
It's actually also check valve. But the design is a flapper.
Oh, so it's like
Remember your fuel cool oil cooler?
Ah.
It's also a check valve. But it's a spring loaded check valve. You allow one way. You allow one way flow. The other way cannot. This way flow to here cannot. You always must get out here. But because spring is minimum pressure required before you bypass. Okay. So the idea of check valve means one way. That's why you're driving your arrow side one way. Okay, this is what it means. You allow one way. It's a flapper check valve is foreclosed by gravity. Okay? Foreclosed by gravity. When this fuel is higher, the fuel will flow from here inside. When the aircraft tilt, the fuel here higher and fuel here is lower, but you trap inside. Yeah? What happens when the fuel tank here getting lesser and lesser? And this check valve is not efficient enough. So they introduce injector pump. The diagram here show that injector pump is on top because of the display. No, sorry. The injector pump is at here, lower level. You pump the fuel into this tank. So where you get the motive force come from? It's come from the boost pump. Remember boost pump is outlet here, right? The tap from here. Okay, there will be a small tap from here. It will flow from here to the tank, circulating the tank. But there's a venturi opening here. By venturi effect, you suck in the fuel. Okay, from this outer tank here, this tank here. suck it in and go into the buffer tank or cabinet tank. Or sometimes call it inside tank. Yeah? It's called a proper injector pump. It's to suck in the fuel. Understand? Remember you got two kind of pump, huh? This is your fuel boost pump. Centrifugal fuel boost pump. This is injector pump. Okay, the one pump is your engine or steam displacement pump. Okay, three kind of pump. Injector pump, without the motive force, it won't work. Okay, kind of slave pump. When this pump working, it will suck. When this pump not working, it won't suck. Okay? Understand? The purpose is to make sure down here got fuel. Make sure this pump is submit in the fuel. Yeah? Okay, you pump it out. Okay, remember, if something goes wrong, this pump wrong, this one fail, or here line broken, the fuel close separating here, or the fuel from other line coming in, so cannot. So you must have a way to isolate the tank. Okay? When the tank is isolated, the fuel remainder here become a dead weight. Yeah? When you become a dead weight, and this fuel here if you keep on using, your aircraft become unbalanced. For small aircraft, not much effect, but become a big jumbo, okay? The unbalance here can become 10 times, 20 times different. Okay? So it is too much for aircraft. What I call is trim balance, too much for that. So you need to do another way, you need to transfer, tank to tank transfer. Okay? The basic way is to open up a line here. Remember the fluid physics, you open the line here, the container here, the container there, automatically your balance itself. Your flow and balance itself. You get the same level. Okay, this is your physics of fluid. When this one is open, this two level here will tend to balance by itself. This is called gravity transferring. Yeah? This is a very common type, using gravity. Let the fuel level here take care itself. It will balance by itself. Okay, this is called gravity transferring. Another time is called pump transferring. That one is seldom used. The most common use one, even for jumbo, also use this one. Gravity transferring by itself. So transfer valve is to transfer fuel from tank to tank. Okay? Then another one here is your selector valve. Okay, your selector valve to select the fuel from where, from which tank you want. Okay? And also have cross feed valve. These two work together, you need to pump the fuel from where you want. To select the fuel from where, from which tank. That's why it's called selector valve. This one is transfer valve. It's to transfer between tank to tank. You need to select the fuel from which tank. Okay? And this valve, nowadays, the design are the same. They look identical. Okay? You can move from here to here, part number the same. But because of location different, their function slightly different. One is to transfer the fuel, one is to select the fuel. Okay? Can this again? Any question? So what is the purpose of flapper valve?
To fly.
Write something to allow the fuel to flow into one way. Trap the fuel inside the buffer tank. Or this tank you can call it buffer tank or cabinet tank. Remember the cabinet? You got minister, normal minister, cabinet minister.
And drum.
The core group. Cabinet tank. You call it cabinet tank. Sometimes you call it inside tank. A tank within the tank. This is inside tank, this is outer tank. It's the way they name it. Just need to tell people that this is this tank. All clear? I say, Yeah?
Yes.
Okay, the next one. Your 4 have lubrication. The 5th is aircraft fuel, 6 is your engine fuel. Okay, come to your exhaust. Before you go there, the one thing to take note. Remember, this is topic 5. This is topic 6. There's something in between. There's a line between here. From here to here. Well, the fuel boost pump all the way to your engine positive displacement pump. There's a line here. Okay? This line is a special requirement. Okay? When the line out of the tank, when coming out of the tank, so look at this schematic. This valve is brought out of the wing spar. It's outside wing spar, not inside the tank, please. And it calls power valve. Also called LP cork. Okay? Also called low pressure fuel shuttle valve. Okay, different name only, but same person. Yeah? So by law, you might have this valve here. It's for isolation purpose. If something wrong with the engine, you have to shut this one. So it's by law, mandatory. Yeah? Okay, this is the boost pump. The purpose of boost pump is to give you a positive feed to your engine pump. Yeah? Understand the concept? And this is pretty dead for fun, it's by law. By design, you must have this. Okay? Okay, I'm not going to show you this diagram. You also need to have one more. Olden day there's a LP pump and SP pump. Nowadays only this pump only. LP already they don't use that anymore. You just need to increase this pump. This pump capacity increase 20% more. This one no more. Okay? But the filter is still there. The cost filter is still there. This is called a cost filter. Or sometimes called strainer. Another name for cost filter is a strainer. Okay? It's a mandatory. You must have this one. Yeah? Okay, after your pump, okay? This pressure here is used as your hydraulic.
Oh, hydraulic.
It's your fuel hydraulic to actuate your engine actuator. Your engine needs to have muscle to move the valve, to move all the vein, to move all the big valve. Okay, need muscle to move. Okay? The muscle comes from this one. Come from the fuel hydraulic. Not the aircraft hydraulic system, please. Don't get confused. You're using fuel hydraulic. Although the engine drives a hydraulic pump, and this pump is to drive the aircraft hydraulic system. But the thing that moves the aircraft engine component is done by here, under fuel hydraulic. Understand? Do not get confused. Don't confuse with the aircraft system side. Okay? Your aircraft fuel hydraulic comes from here, SP pump. Okay, remember your FPU compute your meter fuel at the same time. It also command all the hydraulic actuator, all your actuator, all your control. All controlled by your FCU. Remember FCU? Okay, all these things. Finally, you do two things. One is meter fuel. Secondary is this one. All your actuator control by fuel hydraulic. Yeah? Okay, during your meter fuel, okay, they usually over design a bit. The fuel flow more than requirement. Okay? Because of this, there's some spill over. Or sometimes you got a bit of back pressure need to release. Okay, all this will dump back to the where? To the pump inlet. They do not dump back all the way to the fuel tank. They dump back all the way to the fuel tank, you revert back to zero. You pressure back to zero. Wasting of pipeline, wasting of pressure, energy. You dump here faster. For example, here is 500 psi. You dump here is you only drop to 200 psi. Then straight away pump again. You become more efficiency, correct? You dump back to the tank, you go back to zero. You pump again. From 0 to 500, you need more energy. So energy wasted. Yeah? So the dumping is not dumped back to tank, it's dumped back to inlet or the pump. Okay? Then out with your flow meter, then your filter. Another filter, then go to all your nozzle. Okay? Then another component is also mandatory. That is your HP cock. Immediately out of your regulating valve. Before you go out to the nozzle, you must have a HP cock. Yeah? To shut down engine is done by HP cock. For immediate shutdown, normally immediate shutdown of engine is done by HP cock. If HP cock fail, the emergency shutdown is done by LP cock. Done by here. Remember the law stereo, this one is a mandatory requirement. This is emergency. Yeah? When you put finder, your finder is pull this valve close. Okay? So engine will shut down until all the fuel here burn out, no more. Then the engine will shut down. Yeah? But to shut down engine immediately, you have to shut down here, correct? But here is near to your nozzle. So your engine can shut down faster. Okay, this one is HP cock. HP cock used for normal engine shutdown. High speed. Okay, HP cock. Okay. High pressure fuel shuttle valve. Okay. Last time the nickname is called HP cock. You look at old text too, you put on there HP cock. COCK. I know this is the rooster here. Okay, remember your fuel control unit. Remember the 8873. You manage the fuel. Manage the engine fuel, your metered fuel, okay? You need to have 4 primary parameters. So what are the 4 primary parameters? The first one is your pilot command. You set your throttle lever angle. Remember your throttle lever? Okay? That's why you call PLA. Power lever angle, you can call it throttle lever angle or thrust lever angle. Different textbook give you different name, okay? All mean the same thing. Pilot got to give command. I command this engine to give me part power. I command this engine to give me full thrust, take off power. I want this engine go either, you go either, okay? This is called command. The next one is your compressor inlet throttle temperature, your TT2. Your TT2, remember the formula. The last component, area temperature difference. The pressure difference is the exhaust pressure over this pressure here. It's the same point, this is temperature. Remember in atmospheric pressure, temperature, volume, they quite fixed. They follow a fixed reference. By knowing the temperature, roughly you know what is the density, what is the pressure of the atmosphere. Yeah? That's how they measure temperature. You know. At this temperature, your atmospheric pressure will be so much. Your atmospheric density will be so much. That's why they have to measure this temperature. Yeah? TD2. We know your formula got problem. Your P2 minus P1. Where is P1? So it comes from here. Compression inlet total temperature. By measuring the temperature and the you know the pressure, you know the density. Yeah? The next one is your engine RPM. Remember, you want to push up engine, you need to increase RPM. Just like your car, you put high power, your engine RPM will ramp up, right? It's the same thing. You give more push, your engine RPM ramp up. Either power, engine RPM reduce. So RPM is important. They always remove N2, please. Most of the time people use N2. But some people use N1. It's up to the design. Okay? The next one is your burner pressure. Burner pressure is your diffuser pressure. Please. Diffuser pressure is not so high temperature. Easy to measure. Okay? You go and measure combustion chamber pressure, it's difficult. You probe the way out faster. But this one they measure the diffuser pressure. Okay? When engine stall or engine lose power, the first thing that affect is this one. Burner pressure will be affected. So FCU can send this change. If the pressure change too much, the fuel control unit will know something wrong. If the pressure drop, the engine will die. So FCU need to respond. Keep more fuel, continue injection, all these things will cut in. All measured by this one, burner pressure. Okay, so what are the 4 things?
Power level, angle,
Power level is a pilot command. Please explain power. What is power level angle?
The lever
Pilot
angle.
command.
How much thrust?
The TT2 is to measure air density.
Yeah.
Ah,
Compression,
To avoid
compression stall.
Stall.
Okay.
Easily.
Burner pressure,
weight
Wait,
of
wait.
air.
Wait,
max airflow.
Yeah, max airflow to the engine.
Okay. Now,
Yeah.
FedEx.
remember you are from FCU, go to EEC, then FedEx.
FedEx.
Okay.
Easy to forget.
Remember, EEC is a transition state. Huh?
Hydromechanical.
EEC including
No.
premature FedEx, but hydromechanical unit
And
plus valve unit. Huh? When EEC fail,
Then just hydromechanical.
you lost all the secondary function, but the primary function still there.
Yes.
Your engine still operate as per normal. Not really normal lah. A lot of automatic control gone. Other need to control closely. But engine still work. The EEC fail. But later on, people become more and more computerized. Develop become FedEx.
Yeah.
Okay, this FedEx, this one the name called full authority.
Yeah.
The computer become more and more smart. Okay, you get more and more full authority. Authority given to the computer itself. Okay. So pilot got less command, less control now. Pilot only left one more control to shut down engine. Okay, this one does not give to the FedEx. Shut down engine command must come from pilot. So what are the advantage? Hello.
There are the advantage.
No engine trimming,
Yeah.
no overspeed, no overtime.
Chưa.
What is the FedEx schedule fuel yaw or in accordance with?
Okay.
Say
Finish.
again.
Finish.
Oh, this one.
No.
Just good.
The fuel flow can be adjusted for make number, total temperature. Remember your remember FCU I mentioned to you? You only measure the 4 primary. How about the secondary? Is it got secondary function, correct? The secondary function, remember your actuator movement, your big valve control, big valve shadowing, sub shadowing. Okay? Your status vein configuration. Remember this is your the vein store shadowing.
Yeah.
This is what you need. All is controlled by your FCU secondary parameter function.
FCU second.
So this one is also done by FedEx.
FedEx.
FedEx take over the command.
Then send me.
Yeah? Take over command. So what are the advantage?
No, yeah, those are the advantage.
Now computer is much better than humans. If not, the flight engineer got to do all the trimming all the time. No? Manually do it. No? Now all done by computer. FedEx do it. No more overspeed, no more overtime. Remember you put out takeoff power to maximum. You got to watch out the limit. The maximum RPM, maximum temperature, engine can hold how much. Watch out. Remember your lap. You push out, you got to watch all the gauge. But with FedEx you don't need.
Video will be outside.
The computer take care itself. No matter how you ram, you won't overboost. You won't overtime. This is what it means. Better engine starting at various atmospheric conditions. Remember your engine start schedule. You have to control the start bleed valve. Control your temperature. When temperature low, you need to increase more fuel. Last time you got to do manual trim. Remember when last time
I don't know. How do you put it?
where's your anybody got grandfather driving car?
Ah.
They're using carburetor, correct?
Yeah.
Every morning the engine cannot start. Right?
Yeah.
You have to put a choke. Right?
Yeah.
cooling choke is doing this one.
Oh.
You get engine more rich mixture, so the engine can start better. All these things can be automatically controlled by your FedEx. FedEx take care itself. Okay? During winter season, your start sequence different. Okay, summer season, start sequence also different. All take care by FedEx. You know the engineer can go and adjust it there before engine start. Okay? To save all the trouble. Okay, improve the engine brake schedule. Remember engine brake? VSD actuator control, or the V-pump control. All automatic now. Okay? You know last time mechanical, you can do rigging, cable, push-pull cable, rigging, all this thing. Now no need. Now computer take care. Okay? The turbine K active cooling, remember the ACC cooling? Turbine K cooling?
No.
Turbine K cooling using what cooling air to cool? Using fan air, please. Turbine case cooling using fan air to cool the turbine case. Not cool the turbine plate, cooling the turbine case. And this one is controlled by your
FedEx.
no total sticker bomb.
FedEx.
Right, total sticker bomb. Higher efficiency.
Yes, of course FedEx.
Dulu kau pernah terbaca.
No, I think more and more. A lot.
Advantages.
Oh, this is the seven basic one.
Apa kau cakap?
Cikgu pun perfect ni, tapi kita pun macam advantage ni. Kau cakap advantages.
Aku masih tak faham.
Siapa tu dia dok?
Tedrik.
After your engine.
Dia nak apa kita pergi.
Ini ada.
So after your topic 6, now come to topic 7. Okay?
Yay.
So tak ada lah.
Ada dia ni ada.
Topic 7 talk about exhaust. Exhaust got the normal exhaust and the reverse. The normal thrust and reverse thrust. Okay, For turbo jet engine, can only apply what kind of reverse thrust? Hello, listen here. For normal jet engine, your F-16, F-15, or the military aircraft, they're using the turbine shell, correct? It's only a turbine reverse, or gas reverse, or hot stream reverse, because they don't have fan stream. Clear? Only turbo fan got fan stream. Then you can have cold stream reverse plus your gas reverse. They can apply both or apply either one. All clear? Turbo propeller don't have. Turbo propeller they don't have kind of reverse system, but they have their own. They just need to reverse the propeller to become negative. Instead of push the air backward, they push the air forward now by the propeller. So propeller work different. Clear? Okay. When you talk about exhaust, your engine exhaust, okay, the one special condition is called a choke condition. Okay. So you must understand this principle of applying choke condition. Do you able to explain? Don't say no lah, must. Do you able to explain? I said yes. Do you able to write? Got to say yes. There are two conditions, one for sonic, one for supersonic.
Supersonic.
Okay?
Subsonic.
Out here, for the sonic side. Engine have exhaust operating at choke condition, and hot gas can longer accelerate further to the higher velocity. It comes to choke condition, it's like within near to sound barrier, your velocity cannot increase further already. Almost stop, but it's still moving. Remember the oblique wave, not the bow wave, the oblique wave. Okay, it's a sound barrier, but it's moving. Okay, Okay, the energy of the gas will then be converted into pressure difference. You convert a lot of velocity energy become potential energy. And with this, you created a very high pressure difference. Yeah, this is called choke condition. Able to explain this one? This is for sonic.
Which one is the pipe?
For supersonic,
Exhaust pipe.
because of this duct.
Which one is the exhaust
It's a
pipe?
convergent divergent duct.
Exhaust ah.
The neck,
No, I mean there's
your
exhaust school.
choke condition. You choke at the neck.
But which one is the exhaust pipe?
Okay?
The whole thing.
If you're doing this one,
Apa that one?
if you change this nozzle area, what is the side effect? Remember, at different aircraft at different speed, you have a different nozzle area for the military aircraft. Because commercial aircraft by doing this is not efficient. Doesn't gain anything. That's why they remove away. But for military aircraft, yes, because the speed range is wider. You need to have a change in nozzle area. To change a nozzle area, you got a side effect. What is the side effect?
Huh? Oh, yang 19 part.
Your engine RPM will be affected. Your engine EGT affected. Okay? You lose certain benefit.
Bro,
Your engine RPM and exhaust affected.
Ramadan.
This is your side effect.
bro.
Okay, If you change your nozzle area, okay, you're going to affect your RPM, affect your engine EGT. Okay, after exhaust, you come to your fire detection and extinguishing, your topic 8.
You have to pay attention to
Find the
this.
fire. Oh, oh. Just now. No. Ah, yes.
Ya.
Yes, yes.
Aku dah pernah ambil gambar.
Okay, for the topic 8, the fire detection.
Dah lah.
So what is the primary principle of fire detection? Primary,
Aku dah pernah ambil gambar.
The primary function of the fire detection, it must have what? May have two things. Hello?
Ah,
Fire detection may have two things. One is your,
detect then that one.
it must give you fire warning,
Yeah.
the alarm.
Yeah, that one.
The second one is your indication.
Extinguishing. The
At which
indication.
area
Then
the
piang,
fire.
piang,
Okay? This is your primary function of your fire detection.
Yes, my family.
Then the pilot decide whether want to extinguish or not extinguish is done by the pilot.
Yeah.
So this is the army and fire.
Let it go. Oh.
Okay?
Oh. Jap.
Okay?
No.
So what are the, answer these two questions. What are the classes of fire?
Ah, A, B, C, D.
A, B, C, D.
EMG.
Yes.
Oh, understand,
Yeah.
A mean what?
A means A.
A means solid.
Solid.
Here, solid.
Yeah.
This is solid.
Solid.
B,
B is yeah, liquid.
C, look at C.
Yes.
C is
Electrical.
Electrical, yes.
D,
Metal.
Okay.
That's the only thing I know.
Oh no.
So what is the basic requirement of fire detection system?
Must detect.
Got fire lah, got smoke.
Must able to detect lah. Must be robust enough. Other got fire, the detector also burn, also no use one. It must be can withstand fire.
Yeah, it's the fire.
Then must accurate to tell you there's a location. Don't give you wrong indication.
Okay.
Let engine fire, they tell you right engine, something wrong.
Very wrong.
Okay, can you recall back to your lab, the last lab, engine ground run? Engine ground run, okay? Engine ground run, when the engine fail, what is your response? And what are the causes?
SCU also everything.
Hello, engine fail.
Yeah.
What is the common engine failure?
Hot.
Engine no light up, what happened?
Engine no
No
light.
light.
Then
Low light mean what?
cannot fly ah.
Low light mean no ignition
Ah,
lah.
yeah, ignition lah.
No fuel, how to burn? No fuel.
Ah, correct.
Ya lah, dia benar.
FCU failure, no fuel.
FCU failure.
No
FCU
lah.
failure.
That's what they say you. Effective fuel control, FCU failure. No fuel supply. No ignition. Say no light up.
Yes, yeah, everything FCU.
Okay?
So what your numbering wrong?
I copy here, copy there, the number. Okay, let's think of a few more failure. What is hot start? Hot, very hot.
Hot.
It's hot.
Ah.
The temperature hot.
Mean your temperature rise too fast.
Yeah, rise too
It's going to
fast.
hit your peak engine. So you must shut down engine immediately.
Yeah.
So what is the cause of this one?
FCU failure.
Your igniter plug.
Too fast. Light up too fast, man.
Listen to what I say lah. Hot start mean what?
Temperature rise too quickly.
Very quickly lah. It's going to shut down engine immediately. So what is the cause?
FCU failure.
FCU failure. Wow, very good.
You're right.
You know the common term,
Yes,
FCU failure.
Yeah.
Okay?
Everything is about
Because FCU failure defective can cause a lot of things. It can cause no light up, hot start, hung start because of FCU problem.
Yep.
Well, what is the next frequent cause?
FCU failure.
No.
High
Your
oil
igniter plug, not the spark, not strong enough. You keep causing incomplete combustion. You're going to have a high EDT. Okay? Your starter defective. Instead of after ignition, it's supposed to increase faster, but it increase too slow. Oh man, cannot run. And now your temperature overtake you. Because become hot start. Okay? Your fuel drainage blocked. And some member the fuel extra fuel spill out. Instead of transfer back to inlet, it still stay in the combustion chamber. What happened? All the fuel will burn now, so your engine will swap. Okay? Your engine will burn. You can see the side of the engine now, the fuel come out. Will burn. Okay? Because the engine swap. Okay? Now what happened to the hung start? See hung start here?
No. FCU.
Sudah.
FCU. Don't have.
No hang start.
No hung start.
Oh.
There. Hung start. There. 3. Number 3.
Hung start, yes, number 3.
There. FCU failure.
The main purpose hung start means your engine cannot achieve either RPM. It's called hung start. Means a certain time. It hung. Okay? Who to blame?
The pilot.
FCU lah. The next one is your starter. Your starter too weak. Cannot accelerate.
Who to blame?
So also to blame also. Okay?
FCU.
FCU. Okay? Starter or compressor. The compressor too heavy. Remember your start bleed out, your open part properly. Your compressor become too heavy. Too heavy to crank. So you have start from hung start. Yeah?
Yeah.
Last one is your low oil pressure. After engine start, engine oil pressure will increase. Or increase slightly. No oil pressure, engine got no lubrication. You cannot continue the start. You must boost the start. Okay?
Abort.
Abort the start.
What?
You must abort the start.
You cannot say
Start
FCU
engine,
kalau
okay?
ada oil.
Because no
That's
oil
the only
lubrication.
thing.
So what is the cause of no oil pressure?
No oil pressure. Low oil pressure.
Defective gauge.
Oil
Oil
pressure.
pump failure lah. Okay, your oil filter clog, all this won't come in. Okay? Defective oil pump. Or maybe the gate give you wrong reading. Actually, there is a oil pressure there, oil flow there. But the gate give you wrong reading. But pilot will still treat it as positive actually. Yeah? Because pilot kiasu. Okay? If the reading still reads 0, you assume there is no oil. Okay? You're shut down. To play safe, okay? Okay? Then come to engine starting system. So what are the 6 engine starting system? The first one is what?
Starter.
A starter. Called pneumatic starter.
Pneumatic starter.
Why we use pneumatic starter?
To start the engine.
Why don't choose other method? Why use this one?
Higher power to weight ratio.
Correct. Higher power to weight ratio. Small starter can crank a very big engine. This is what it means, huh?
Is it
Power to weight ratio. If your aircraft is small, engine is small, you can use a what?
excited?
This one is what?
Electric starter.
Electric
Oh,
starter.
electric
That is your car, okay? The car using a electric starter.
You see exciter.
Other people found, how come this electric starter, if the engine go reverse way,
Excited is what?
after engine start, engine can motor the starter, right?
Ignition.
It become a generator. So it become this one. Dual function. Starter come generator. Okay, after you crank out, you are being cranked, okay? Become generator. Now during the war, this is during war time, okay? During war time, you go to airport, jungle airport, you don't have ground air supply, you don't have electrical supply. So how? Your aircraft cannot fly.
Maybe
So what you have?
You push.
What you have is actually gunpowder. So you put gunpowder here.
Go at
So
high.
you ignite the gunpowder, you create pressure, you turn the A turbine. Then the engine starts. Yeah? Okay. Then another one is seldom used. I think never used. You run a micro turbine engine. You run a micro turbine engine to crank the bigger engine. Okay, this method does not apply to aircraft. It more apply to the steam power plant. The steam power plant, the turbine is very big, very huge, like a huge building. So how to start this huge building turbine? They use a gas turbine, a small gas turbine to crank this huge turbine. Okay, this is what it means. Using a mini engine or micro engine to drive a bigger engine. Okay, this is your 5th method. So what's the last method? Remember the lab SR30. We are using this air is directly impinge on the compressor and turn the compressor straight away. Okay, this called direct airflow method, impingement method. Not impinge on your president, please. It's the same thing. The air supply, pneumatic air supply. Either come from APU or come from ground air source. You put a ground air compressor to supply this. Okay, how to connect ground air supply? Last time you have you need the ground air connection. Connect it up. After engine start, you'll disconnect. Okay?
Yes.
So come to auxiliary power unit. There's one unit the aircraft carry on board. Aircraft. We call auxiliary power unit. It's actually a small engine to run during ground operation. To supply 2 things. What are the 2 things? Pneumatic supply and the electrical supply, okay?
And the what?
Because during on ground, your aircraft waiting dead. You need to have pneumatic and air. So pneumatic and your electric. So this one will come from your auxiliary power unit. You don't have auxiliary power unit, you need to have a ground power unit. Sometimes the A stands for auxiliary power unit. Sometimes people call it airborne power unit. Okay? You don't have this one, you might have a ground power unit. Okay? Any question? No question will become your good luck. Okay?
I don't need luck. I need you to just give me all the answers. Why would I need luck?
The referring can
I just remember.
review for every chapter. Oh yeah, that one. You want to see that one?
I dapat you know. I dapat.
Iya, tu memang ada. Itu ni. Itu number 10. There's nothing on it.
Okay, this is our review.
Ambil gambar.
Come on, topic 2, there's every lesson. Before we start topic 2, there's a topic 1. So this is topic 1. Okay? So what is the position of the inlet valve during power stroke of this reciprocating engine? Remember power stroke? When everything ignite, explode. When thing ignite, explode, everything will shoot up. So all your two valve must be closed. Inlet and outlet must be closed. If not, all your special gas escape. Clear? Power stroke, your valve must be closed. Both valve must be closed. If your valve dirty, doesn't sit back properly, you are going to lose power. Okay? That's why you got to send your car for workshop to grind the valve. To do the top head overhaul. No way car no lah. What do you mean the top head overhaul? So name 4 type of gas turbine engine.
Turbo prop, turbo shaft, turbo power.
Haris diam.
Okay, you understand? So what is the difference between Octo cycle and Brandon cycle?
They are both different.
Constant
So what is
Constant
Auto is
volume,
constant
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 pressure.
pressure,
one
constant
constant
volume.
volume, one constant pressure. The other one? But the 4 function is at
Oh, they both have the 4
one
functions.
is at one location,
Another one in the
one at different location.
Yes.
Okay, piston engine is at one location, turbine engine at 4 different locations. Okay.
Oh yes, there's another difference.
Then the major section of the turbo jet engine. First one is your intake, followed by
Compressor,
compressor.
diffuser.
Remember, sometimes there's a fan there. But people usually sometimes people take the fan as a compressor also.
Ah,
Your fan inlet pressure also a compressor inlet.
Tu je aku tulis.
Be careful of this.
aku belajar banyak.
Be careful because it lost flow.
Kan kau
The
belajar.
fan inlet they call it fan inlet pressure. But in GE, the fan inlet is called compression inlet pressure.
Tadi dulu.
They don't call fan. They call it first stage compression.
Because what?
First state.
The first stage compression is actually fan. Okay? So be careful on the term use. So followed by your intake from low pressure compressor, high pressure compressor. Next one after compressor is what?
Diffuser, turbine.
Diffuser is just empty space, divergent empty space. Increase the volume to give you higher pressure, slow down the velocity a bit. Okay? Stabilize the airflow. And then is your combustion chamber. The nozzle, ignition come in, okay? Yeah?
Chamber.
The nozzle is to atomize the fuel. Not to burn the fuel, nozzle is to atomize the fuel. The burning takes place at combustion chamber. Yeah? Nozzle to give you atomize the fuel, give you the correct fuel air ratio. Okay? So the burning done by combustion chamber. It's supposed to burn at constant pressure for turbine engine. After that, come to your nozzle guiding and your turbine.
Turbine.
After turbine is your
Turbine
Exhaust.
exhaust.
exhaust cone.
Cone, yes.
Okay? Then your
Like
exhaust pipe.
Exhaust pipe.
Then
Yeah?
You split the stop, then each stop.
Okay? So this one over.
So if you got 51 stops, it means you got the primary shares. Is you own the company.
So topic 3.
Oh.
Cold section. You only done intake, compressor,
So it means
diffuser,
you own one out of 100.
accessory mounted where?
So if you own 51,
Accessories,
Accessory
you buy
gearbox.
51 out of 100.
gearbox and turbo prop.
It's always bound below.
More below, yes.
Remember your
Right, you got the
take from your N2.
how to say
And
N2 is your tower shaft. Come down. Where's your N2 compressor? It's your high speed compressor.
high speed.
Protector
So
from there
people
come
they
down.
like they buy
Then
So
extra.
you
become-
mount your gearbox down
So
there.
maybe they buy $5.
Low your
then they put
low your high
so
speed
stop,
compressor.
become $7.
Okay.
Then they sell.
You mount your gearbox there.
Inlet
So your inlet duct
divergent.
that what? Conversion or diversion?
Divert.
Divergent.
Diversion, huh?
Air
Your
convert.
air expand and convert velocity into pressure. Slightly only,
Have
huh?
available inlet duct.
Slightly, huh? Okay, your supersonic aircraft has variable inlet duct.
Converge divergent.
CD.
Remember your supersonic? It's a
Supersonic.
Venturi duct, right?
Mm.
Yup.
It's a convergent, divergent duct. And this duct is a neck here.
Yeah, there's
Narrow
a
neck.
neck.
And this neck is variable.
Variable.
It change.
Can change.
Okay, exhaust also similar, also change. Okay, and this change is to give you what?
To get
Both of them give you the same similar function. Choke.
choke.
Oh, choke
Ah,
condition.
choke.
Yes,
To slow
pressure.
it down. Slow the airflow.
So,
If the
Slow
airflow
down
at
airflow.
supersonic speed, can you light up the engine? Remember your candle, you light up, people can blow you away. You cannot light up the engine, no problem. So you're going to slow down the airflow.
differential
Then
Okay.
pressure.
the
That's why you choke it.
pressure becomes
Oh.
Ah, centrifugal pump,
impeller.
pneumatic centrifugal pump versus axial pump, axial
Oh.
compressor. Centrifugal pump got what kind of feature?
Impeller diffuser manifold.
The impeller, diffuser,
Manifold.
manifold. Okay? Centrifugal pump is using centrifugal force
Centrifugal force.
to increase the speed of the airflow. When you heat the diffuser, it becomes slow down. The pressure will increase.
Pressure will increase.
Centrifugal pump got higher compression ratio per stage. Axial flow per stage is lower. But axial flow you can cascade it, compound effect.
Cascade effect.
Then you get much higher compression ratio at the end.
What's higher compression?
Yeah? So what is bypass ratio?
Fan bypass.
Bypass.
Fan air.
You are comparing the fan air with the engine air for burning. Compare these two air ratio. Okay? Remember the lab using JT8D is the low bypass engine. It's the initial introduced on the turbo fan engine. Because that initial design is a jet engine, correct? Later on people introduce fan. And they ducted the fan, become a turbo fan engine. And this fan is getting larger and larger. From a low bypass, medium bypass, and high bypass, and super bypass. Yeah? Your Trent 700, 7800, these are all super bypass engines. Fan ratio is more than 10. Oh, this one. Compressor brake AOA determine the velocity of the air. Remember the air coming into compressor. It's determined by two factors. Your vector diagram, your vector airflow. One is the air coming in, the velocity coming in, and also the rotor speed. You're going to have a resultant airflow, correct? Yeah? When there are enough blade stalling, the compressor will
Surge.
surge. Remember this one stall. People in front block you, behind cannot move out. Step by step, all block, all choke up, correct? Then become a stall. Surge, sorry. Stall become a surge. So if you're going to have a surge margin, you have a surge control. You're going to have bleed valve control. This come in. So FCU come in. All in the mind now?
When they touch the
We're
case.
talking about all these things.
Sounds familiar.
Okay, varying stages of high and low pressure of the stator bay and rotating blade produce a cascade effect. Cascade effect. So what is cascade effect?
Like the one you
You are compressing the air from low pressure to high pressure. Again, the nature. The nature flows away from high pressure to low pressure, right? But now you're going reverse way, you compress it. It's called cascade effect. The ability to compress the air. Okay? The blade attached to the disc is by
Upgradable.
compressor using what? Turbine using what?
Huh?
Huh?
Compressor section, the blade attached to the disc,
Upgraded. Oh,
the
first.
dovetail.
Dovetail.
Turbine,
Turbine for 3.
bird 3.
Oh,
Yeah.
that's what I see.
How to prevent tip loss? Compressor tip loss prevent by what?
Upgradable.
Variable tip, variable strip.
Strip.
Oh, turbine?
Variable. No. No, it's also no.
Using what?
Upgradable.
Let's see. Interstage.
You know about tip,
No.
the tip glue?
Variable.
You need the ACC case cooling.
Loss of mass airflow. At the
ACC case cooling. Maintain the gate properly by ACC cooling. Diffuser.
location
What is
and
function of diffuser?
Diffuse.
Just a divergent stay to give you higher pressure, lower velocity. Okay, this is the purpose of diffuser. Sometimes stabilize the airflow. Compressor blade designed with a twist. Why you design with a twist?
correct pressure gradient.
Because the velocity and MV diameter are different.
So they twist.
To maintain the same AOA, got to twist it. Clear? Remember when you turn, auto turning, the speed at the core is lower. The speed at the outer tip is faster. The AOA angle got to change according to the speed. That's why you twist the blade. The function of the mid-span stroke, what purpose of mid-span stroke?
Prevent flutter.
Prevent flutter.
Better fluttering, prevent vibration, okay? No, understand you well.
What's the Mac for?
Lubrication. Skip the first question. Okay, good combustor. Okay. Skip the one. What are the 4 types of combustor?
Multiple can annular, annular and reverse flow.
Reverse flow. Okay, all simple one. When it comes to nozzle guide pin, nozzle guide pin has the highest one. Higher temperature, higher pressure, and the highest flow. Okay? All happen at the nozzle guide pin. You have the highest potential energy down there. Okay? Turbine absorb gas energy to drive what? What is the purpose of turbine?
The bind is to drive the compressor.
To drive the does not produce thrust, please.
Does not produce
Although you call it turbine engine, but turbine don't produce thrust. Okay?
Drive the
turbine
compressor.
Drive
engine is
the
just the
compressor.
engine, right?
The purpose is to serve the compressor.
Yeah, to
Yeah, they drive the compressor lah.
Okay, for turbo propeller, the gas energy is converted into
Yes.
Gas energy is
go
called
to shaft horsepower, need a shaft to turn. Okay?
straight.
Whether you turn another machine or you turn another propeller, you turn a turbo shaft engine.
Aku tak cakap benda fusion tak tu.
Turbo fan, you turn the fan. What is our common P blade failure? Your single crystal, your grip fatigue corrosion. Grip after your under stress, your blade become longer and longer. It's called gripping. Okay? The fatigue. Too much cycle. Become fatigue. Like corrosion. Down the oil, put your oil. Oh, you can skip, ah.
Okay. Not going to.
What is wet and dry?
One is wet.
One is the term wet lah. One is dry. The sum is wet. That's why you call wet. When the sum is dry, it's called dry. When you refer to the sum, you don't refer to the oil tank. It can be oil tank. Mostly people refer to the gearbox. the place that contains gearbox is called the sum.
Ah.
Okay? If this sum is wet, it's called wet sum. This one is dry, it's called dry sum. Okay? So how to prevent this sum not wet? You have to pump it out. Lah. So you got a scabbing system. If you don't have scabbing system,
Then you
the
cannot go
oil
back.
stay there. So it's
Yeah,
not
stay
wet. Yeah? So dry,
Oil can be
dry
wet
sum
or
got
dry.
dry sum system
System.
got because it's got scabbing system. You're going to have two type of lubricating system. What are they?
Ah. Oh.
One is called hot, one is
And
called
then
cold.
cold.
Pasal
Oh, that one.
Dry sum got hot and cold oil lubricating system. Why you call hot? Why you call cold? Because of the cooler, correct?
Cooler.
Where you put the cooler?
oh, the fuel.
You put the cooler at pressure side. When you come to return, your oil become very hot. It's called a hot oil tank system. Clear? You put your cooler at the scabbing side. When your oil come back, before you go to the oil tank, you cool first. The oil are relatively cool. That's why you call a cool oil tank system. Okay? Ball roller, all this. So what is the ball?
Oh, radial and that
Ball
one.
can carry
Axial.
both sides, radius and axial, okay?
Yeah.
Your roller only carry
Radial.
one side,
Radial.
okay? One side only,
Radial.
Your roller can be this way or can be the other way on. So one way only. Carbon ring and red ring. Motorbike engine using two kind of seal, carbon seal and red ring seal.
Don't see the first thing.
Because of the high speed rotation. Other sealing method cannot apply. Okay. Carbon seal may have what? Hello. You might have carbon seal and
Labyrinth.
raise, better surface very rough. Okay, you got a raise.
Or yes.
The red ring seal
No contact.
no contact. It's just prolong the air path by using a red ring. Your mace, okay? Take the air leak through directly, you go to a mace. By doing this, you reduce the air loss, the oil loss. Right? Clear? Because of red seal, you have a constant oil consumption. You're going to have a limited oil loss, please. Red seal is not 100% seal. That's why you got a constant oil loss. That is normal for turbine engine. Okay, oil tank, oil filter, cooler, oil pump. Oil pump is a positive replacement pump. Okay, got oil pressure pump and scabbing pump. Usually scabbing pump larger than the supply pump.
Because of
To
fuel
give
tank.
you a dry sum, remember?
Because of air.
Also because of air. Cause the oil to be expanded.
And also to prevent.
Because of air, you need a ventilation system. You remove the air. So the baby called burping. You need to burp the baby after milk. Okay? Same thing. All others can see.
Call my spectrum.
Spectrometric.
Spectrometric.
Oh, and apa?
All
Analysis
analysis
program.
I think can skip this one.
115.
The Zerati not coming out. Then what is the four feature of the fuel? Four feature of the fuel tank.
That tank on Propulsion.
Yeah, something like that.
Oh, that will come out. Okay, thank you.
This magnetic.
Come out, don't come out. Make sure you can write. That's all. Okay, the four feature can write.
Okay.
What?
Feature.
Apa? What feature?
Kau katanya Aaron.
So what is the purpose of fuel boost pump?
Make
Lubrication to the engine side. Okay.
Anything.
Aaron.
Okay. It's a motive force to move your fuel.
Apa? Four functions. Aaron. Four functions.
Yeah.
Four functions.
Oh, okay.
Okay.
Thank you.
Nenteng tu eh.
Okay, for this picture we ask some question here. Hello. Okay, from this picture here, you can see there are primary parameter and secondary parameter that fit into your FedEx. Okay, remember, look at your FedEx here. Your FedEx here, you got 4 primary parameters. What are the 4? Your A, your TT2, your N2, and your laminar pressure. So this must be fingertip. Okay, by the way, you also have the secondary function. You must control the start sequence, search sequence, don't overboost. Okay, don't overtap. All this you have to monitor it. Okay, you have to schedule it correctly. All your secondary function, this is your sensing. All your secondary parameter, all got to fit into. Alternator is your RPM, your N2. Okay, with this, combined with your fuel hydraulic pressure, you're going to control all your VSV, TBD, BBD, all these valve, all your actuator, all your tip clearance control. Somebody going to move the muscle. All done by your, the command comes from FedEx. Not from pilot. Pilot is a dedicated job to FedEx to do. So what the pilot do?
Nothing.
During flight.
Auto.
So what they do, they first read newspaper.
Then eat.
After that, sometimes fall asleep. After that, disturb stewardess. Shh, don't tell them, please. Don't tell them I say one. Anybody pilot here?
No.
Don't have. Otherwise, you can agree with me. This
This
what
one,
I always tell you. Okay?
the steel car.
Okay.
Okay, the steel car.
They come to long haul flight from Singapore to USA. What did they do? They take out this paper. They read. After read finish, they put the newspaper on the windshield, cover up. So no more light. What you see always blue on the outside, very bright. They put all the newspaper. Okay? That's why we have another kind of warning. At least 15 minutes, if the pilot never flip any switch or anything, there's a warning. Tell pilot, wake up, wake up. Yeah, I'm not kidding. It's such a warning. Okay? Every 15 minutes, there's no action in the cockpit, there's a warning will come on. Okay? Understand? So what are the advantage of FedEx? Remember, all pilot is dedicated his job, everything dedicated to FedEx to do.
Not trimming.
So he take care of all the trimming, take care of all the
Overspeed,
overtime,
overtime.
all your scheduling done by this guy.
Yeah.
All automatic. Okay? At the end, you're going to have a higher efficiency. Please mention that, okay?
Yeah.
For all the exhaust, what is the main principle of the exhaust? The exhaust is don't add the air come out directly straight away. Remember the three formula? Momentum of air flow, momentum of gas flow, and the pressure difference. So you must create the highest pressure difference. To create this higher pressure difference, you need to have something called choke. Before the air come out from the exhaust case to the atmosphere. You choke it, but not choke it at the both wave. You choke it at the oblique wave. The air still flow, but the high pressure increase. Okay? It's called a choke condition. Okay? For commercial aircraft, the subsonic aircraft, the exhaust nozzle is usually fixed. So very it doesn't get much benefit, so they fix it. Okay? But for military aircraft, because the range is wider, you need to change this nozzle area to give you a proper choke condition. That's why they change the area. But changing area, what are the side effects? You change the nozzle area to give you the choke condition, but they got side effect. What are the side effects? You affect your RPM. It may slow down your RPM. It may increase your AGT. Yeah? Remember, you choke it, you slow down. Okay? Your temperature will rise up. Yeah?
So
This is your side effect.
oh, the only difference
The noise, all this.
is what's at the exhaust.
Who control the afterburner?
Ada is inside the combustion.
FedEx.
Time to do this.
FedEx.
FedEx, ayo.
SU,
Other people do. Don't do. Okay? Everything is FedEx. I need tell the engine, I want to go over Mach 1.2. FedEx will take, okay, FedEx will take care of everything. Yeah? So other burner take care by FedEx. You introduce fuel at where? At the nozzle, exhaust pipe.
Exhaust.
Oh no, wake up.
So what are the class of fire? A, B, C, D. You are solid. Solid is what? A. Class B is? Liquid. Class C,
C is electrical.
Electrical.
Okay, very good. Well
Metal.
done.
X is
Okay, what are the basic requirements for the fire detection system?
To detect fire.
Ayo, must be independent, robust, safe, must indicate correctly.
Yeah.
Don't let engine fire, tell me right engine, they shut down wrong engine. Become a disaster, okay? They might have fail safe, poor power circuit, poor power supply.
At least tak tahu kuat tu.
But able to self test to tell me if the system still working or not.
Belajar kat rumah.
Okay? Because this is all automatic. I like to know, hey, working or not? So must do a test. Okay? All this blah, the rest of blah 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 blah. For engine, wire detector, there are two types. What are the types? Thermocouple guy, this is using on the pneumatic air leak supply. What about engine side? Engine fire detection using what kind of system?
Thermometer.
Thermistor and what?
Pneumatic.
type.
Pneumatic.
Thermistor is called KIDI system.
Kidi.
Pneumatic system is called?
Water system.
Aduh.
Aduh, mak.
Never heard of Citron Donner, no?
Donald Trump.
Donald Trump, you know.
Pneumatic is Donald Trump system.
You know it's Trumpers.
Make American great again.
What? You know the English term, Trumpers mean what? Trumpers means make something worthless lah. Ignition, come. Ignition, you must have a good spark again. Down here, you must use spark igniter.
Igniter. Exciter.
Okay, spark igniter.
What exciter?
Okay, the two kinds of spark. One is gas spark, one is the surface spark. Okay, surface igniter.
Exciting, right?
Need to have high energy, to give you the good up, good spark. You don't have good spark, you're gonna have what?
Excited.
You could have hot start or hung start problem. Clear?
Auto.
So this is one of the main cause, your ignition can cause problem. Okay? When it comes to ignition, there is something called a horn ignition or automatic ignition.
Spark
It's only
ignited
applied
and
at
glow.
certain phase of flight. So what are the 4 basic phases of flight? When there is auto ignition.
Take off.
Take off, landing.
Cruising.
Cruising
Anyhow.
don't do that lah. Cruising very safe.
Flight condition.
Turbulent flight.
NTIs.
NTI, then there's icing formation.
Yes.
Take off, landing is the 4 conditions.
Ganti special.
When it comes to starting, what are the 6 methods of starting? Pneumatic air starter, electrical gas generator, combustor, mini turbine engine.
Just now carburetor.
Then followed by the last one is what?
Cartridge lah.
Impeachment method.
Starter.
Remember the word?
APU.
When you impeach the president, what happened?
Impeach.
Impeach the
Impeachment.
president, what happened?
Impeachment.
Then it's called impeachment in the parliament. So the president got to come down. Okay? The last one.
That's not the last.
Last one.
Topic 11 revision.
The last one, not much already.
All the way at the end.
Start.
All the way down.
Wait, hang start. Hot start. Hang start mean what?
False.
Hang start cannot reach either RPM. So what are the cause?
The cause is
FCU problem.
FCU failure.
FCU, defective FCU,
Failure.
starter disconnect too early,
Yeah.
your compressor too heavy.
Yeah. Yep.
Hang start. Hot start.
Very hot The temperature
Also
increasing.
FCU problem. Igniter, not proper ignition.
Fuel never
Too
drink.
hot.
Shut down fuel never drink.
So that fuel is still remaining fuel, okay? No lab,
Ignition problem.
no ignition, no fuel. No ignition, no fuel, mean cannot start. Okay, the other one is FCU problem.
FCU.
Remember the start sequence, who control it?
FedEx.
FedEx lah.
FedEx.
You are very good, man.
Yeah.
Let's stop here. We not faster than you.
Yeah, don't.
Dah.
Show us the left solution.
This instrument,
So you got one more you need to show us.
Aisha, solution.
No more file you need to show us. Exam solution.
how many color are there? How many color are there?
Oh, 3.
What's the white color for what?
White for advisory.
Just tell you.
Just tell me only lah.
Yeah, white for advisory.
So let the engineer do the job lah.
Yeah.
Then the yellow?
Cautionary.
Caution. Not immediate warning, but doesn't require immediate action. A bit of delay action, okay? The mother can bring your coffee first, then do the action, okay? That's your bleed failure, left engine bleed failure. You can get everything steady, then you isolate the bleed. Okay, have some time to respond. The red color mean what?
Warning.
When engine on fire, can you wait or not?
No.
Cannot wait, this urgent thing. Okay, must do action, must do something. So next week is your exam. You need to wait now.
Yes.
It's a yellow or red.
White.
Blue.
Why still white? So ask me to give you another revision.
Yes.
I'll give you a revision Tuesday or not? After exam.
Okay, solution.
For what? Monday morning. The Monday morning solution.
It's no time here, please. That should be the red button. Okay, you must start burning fuel already. Burning your candle, please. Any question? If no question, same advice again. Good luck.